Welcome to the Yove Studio. My name is Fabian Franke. Today I will explain some things pertaining to issues with garment transfers and problems with transfers that poorly adhere to garments. There are various types of garment transfers that have very different transfer parameters, and thus the possible problems and influencing factors which determine whether or not the resulting transfer will be a success are similarly diverse. The first possible cause of problems is that in the case of any given transfer, the manufacturer's specifications regarding temperature, time, and pressure are to serve and be understood as mere standard values, which may in fact deviate in your respective environment and depending on your heat press. Wherefore, certain adjustments are often required. This can be necessary, for example, in cases of high ambient temperatures, high humidity, or if the heat press model is slightly off from the specifications of the manufacturer. Therefore, don't be afraid to do some short preliminary tests in order to find out which parameters are correct for the given application, even if they don't match the reference values provided by the manufacturer. The next problem is that, especially when beginning a transfer series, it is often the case that the heat press is not fully warmed up yet. Here we have a clamp press made by the brand manufacturer Secabo, the model TC7 to be exact. Just as with almost all other types of heat presses, it is provided with a heating plate, a thermal element, which forwards the temperature to the controller in the press and thus indicates how many degrees the plate is currently at. Yet it doesn't always precisely correspond with the surface of the heating plate because the thermal element is not provided on the surface, but rather inside the material of the heating plate itself. As a result, delays are possible since the thermal element may already have reached the target temperature before it has actually spread across the entire surface of the heating plate. It is therefore advisable to wait a short time after the first signal indicating that the heat press is warmed up to allow some time for enough heat capacity to really develop and allow for a high distribution of the energy. The second thing that often leads to problems are the transfer pressure specifications. The manufacturers of the garment transfer materials often provide pressure specifications in bars, which is mathematically problematic because they refer to the cylindrical diameters of a particular pneumatic heat press. And the use of bars as a measuring unit absent the information which heat press was used to determine this value is completely useless to the consumer, especially when using a clamp press, because with these it's impossible to determine precise transfer pressures anyways. Oftentimes a medium pressure is specified. We always recommend choosing a pressure at which it is possible to close the heat press with some effort, yet without the use of force. If it is too easy to close the press, the contact pressure is set too low, yet excessive contact pressure can also lead to problems, because then the hot glue can leak at the side, so this is also to be avoided. Here it is also recommendable to perform 2 or 3 tests before starting a large production. The next influencing factor is the garment's thickness. If you read that the flex is to be pressed at 150 degrees for 15 seconds, it is not irrelevant whether you press it onto a t-shirt or onto a thick sweatshirt or another type of thick or extra thin material. Because a thicker garment absorbs more energy. That means it drains the heating plate of more energy during transfer than a thin garment, so that thicker textiles require the transfer time to be extended, as it takes a certain time to reach the desired temperature level within the press.
Ein dünnes Textil. Das heißt, tendenziell bei dickeren Textilien muss die Transferzeit verlängert werden, weil es eine gewisse Zeit dauert, bis sich in der Presse das gewünschte Temperaturniveau einstellen.
Another aspect is that oftentimes cover films are used, as is the case in our example where you can see a PTFE foil.
Folien verwendet, wie hier zum Beispiel eine PTFE-Folie zum Schutz von Heizplatte und Textil.
They are a great means of protecting the heat plate and the garment. Especially when working with ink applications such as sublimation and so on, it is important to prevent any color from ending up on the heat plate. Such films or even thicker silicone covers for compensating for unevenness, seams on a garment, or any type of film or an intermediate layer require the extending of transfer time, because energy also moves into these very well insulating types of media, wherefore one needs to press for a longer time. Yet another problem occurs with serial production. For example, if you are very organized in your production process with this heat press. Perhaps there are two of you and your goal is to produce 100 t-shirts. One of you always prepares the shirts and the other one removes the finished transfers. Taking turns like this allows for working very quickly. The efficient workflow means that a pressing operation takes place, the press is opened, another pressing operation takes place, it's opened again, and so on. As a result, the press loses so much energy during the transfers that it can no longer sustain the temperature, whereupon sudden problems can occur after a number of press operations, even though everything went smoothly in the beginning. When working very efficiently, it is important to keep an eye on the temperatures at the controller and, if necessary, allow the press some time to return to the required temperature. With the clamp presses and double plate heat presses such as the Secabo TPD7, we also encountered the problem that the energy from heating up the heat plate does not necessarily also heat up the base plate.
haben wir das zusätzliche Problem, dass die Energie beim Aufheizen von der Heizplatte nicht
In any case, there is a tendency for it to be hotter in the back than in the front. When working with a double plate press, only the base plate located beneath the press head gets warmed up each time. As a result, you end up with one half warm and one half cold base plate when the heat press is completely warmed up. With a double plate heat press, you actually end up with one entirely cold plate. When you now proceed to perform the first transfers, you may encounter issues in the front area. With a double plate press, you may run into the problem that one transfer always adheres well while the other one doesn't. This is because the cold plate simply absorbs too much energy. The recommendation here is to simply close the press when it is warming up. One can simply use the configure transfer cycle to keep the press closed for 15 seconds and then open it again. This will help you to already have more energy in the base plate so that you can achieve a better transfer quality. The last point are environmental factors, such as open windows and open doors or gates. We frequently get reports from customers with problems who tell us that today it just won't work. Our sublimation does not transfer the color correctly. Yesterday, everything was exactly the same and everything worked fine, and then at some point during the conversation we find out that, for example, it's a warmer summer day, so that today the windows in the office or in the workshop are open, and the draft passing by the heat press causes so much energy to be lost that the configured transfer times are no longer correct compared to the previous day, on which the window or the door was closed. Im Vergleich zum Tag davor, wo das Fenster oder die Tür geschlossen war. Vielen Dank fürs Zuschauen. Thank you for watching and see you next time. Transfertipps. Stimmt gerade der Sepp.